So there were a bunch of questions about that homework with the data set, and I thought I'd talk about it for a few minutes. So apparently some people went to the tutoring lab and the tutors were confused how to do it. And the reason for that is that normally when you program something like this, you already have loops available and if statements. And so we don't have any of this. All we know is how to write basic objects. And so it doesn't quite fit into their mental model. So you might have to help them along a little bit if you go to tutoring or at any rate. So here's the deal. You should think of the data set as just like a little machine. And it sees one item at a time. So you could think of items going by a conveyor belt or something, but you only get to see one at a time. And also you have only small amounts of memory. So what the tutors will say, oh, you just put all of the items into an array, but you don't yet know how to do an array, and so you're not and even if you do, you're not allowed to do it. So you only have a tiny amount of memory. You can only remember a few facts about what you've seen. They come by, and later on, after you've seen a whole bunch of data for a half hour or so, as they roll by, each time you look at one, remember a little bit, look at the next one, remember something about it, look at the next one, and after half an hour, someone is going to say, how big was the biggest one? So that's how you have to deal with it. So now let's say that there were actually people, and you get to see them one at a time, like at a police lineup, one at a time. Someone's going to later say, how big was the biggest one? Well, if you're able to remember every one of them, that would be easy. But you're only allowed to remember one of them. So what you do is, you see someone and he's like, that tall. Was he the biggest one? Well, you don't know. There might be a bunch of midgets coming afterwards, so you remember that this one was the tallest height. Someone else comes along who is this tall. At this point, you can forget about the first one, because now you've found a taller one. Then you find one who's this tall. No point in remembering him. You know a taller one. No point in remembering that one. This one is even taller, so you discard the previous one. And all you have to do is you just have to remember the tallest one you've ever seen. That way you don't need infinite memory. It doesn't matter how many of them come by, you just remember the tallest one. So your instance variable is going to be the tallest one. And that was one of the questions here. So let's just do this here real quick. It's a little tough to do that without a pen, but we shall prevail. What was this data set? I should have used BlueJ, but whatever. I'm using my favorite text editor here. So, are we collecting ints or doubles? Okay. So, and I'll call it largest so far. Say, did I give you a name for what to call it, or can I call it anything I want? I can call it anything I want? Okay. And I guess I also have to have one that's, right? Did I have to keep the sum? Was it a part of the requirement to report on the sum or the average or some such thing? No. Okay. In that case, I gave someone a slightly bad tip on desire to learn. I somehow misremembered. I thought that sum or average were also a part of it. So these are the only ones that I need. So now in add value, now let's see. So I'm having a new value, and if that one is bigger than the largest so far, then I want to update it. So if new value is greater than largest so far, and I'm just putting it as comments right now, replace largest so far with new value. Right? But the heartbreak here is we have not yet learned how to do if. So how do we fake that? So we haven't learned how to do if. So I can't just say, if there is an if statement, and some of you may know that if you've taken another programming course, but you're not allowed to use it. So what can we do instead of if? Yes? Okay, just give us a tantalizing hint without the answer. And so the hint is math.max, right? So we need to use math.max. Now someone came to my office hour and said, how does math.max work? And then I realized that I should have told you about something that's really useful, and so I'm going to do that right now. When you start up BlueJ, there's a hidden treasure that you can find by going to View and then Show Code Pad. And then down here comes this thing that's just much too small, so let's make it bigger. And this thing is really nice. It's kind of like a Java pocket calculator. So I can put in here math.max of 3, 4 and hit enter. And it gives me the answer, 4. And so whenever you have a function that you don't quite know what it works, then you can use this little calculator pad here to just ask it. Like, what's another function that we've just learned about? Square root. So you want to know what is the square root of 100, and it just tells you the answer just like that. It works with anything. You want to know how much is 6 times 7, and it tells you that too. So it's just like a little calculator that works with Java expressions. So anytime there's a Java function that baffles you, you can do that. Now you could actually probably write a whole Java program to do that, system.out.println of max 3, 4. But that's kind of tedious, and most people wouldn't really be bothered to do that, right? You'd have to come up with a new class, a new main, and that's no fun. But this little interactive thing is really quite nice. So if you want to know how does max work with negative numbers, let's find out what's the max of 3 minus 4. And it's 3. Why? Well, minus 4 is less than 3, so what else is going to be? Now someone asked me, can max take more than 2 numbers? Let's try it out. I guess the answer is no. So in this case, you just get your usual exception report, and which we don't even want to understand. So it can only take 2 numbers. And so you can just play with it for a few minutes until you have a good understanding of how math.max works. All right, so the key here is to use math.max. And that's going to give, if the new value is bigger, then it's going to give you the new value. And if it's not bigger, then it's going to give you the other one that you put in. So that's kind of the hint on how to do the add value. And so if you now think of this little thing, just remembers the largest value it's seen so far. And then later when you ask it, what's the maximum? What is it, get maximum? So how do we know what's the maximum?
You haven't, I mean, don't you have to put like a get maximum for like an instance variable? Like,
Yeah, I know you know. Okay, don't I have to put an instance variable? But I have an instance variable.
like near the beginning, you have largest so far,
Yeah.
smallest so far.
Yeah.
So is get maximum like is it like its own method like?
It isn't. Yeah, that's what's part of the specification. The specification said write 3 or 4 methods. One of them was add value. One of them was it called get maximum or was it called get largest? I don't remember. Oh, I'm sorry. Maybe that's
Close enough.
yeah. largest. There we go. Okay. Same question. How do I implement it?
Return the variable?
Yeah.
That's what question is. Should the logic be in the getter, or should the logic be in the add value?
There's no one straight answer. Sometimes the logic is in the getter, and sometimes the logic is elsewhere.
Because I tried to put the logic in the getter, you'd have to carry an array.
That's right. In this case, I don't see how you can put the logic in the getter.
Yeah, it would be a little
Because we don't
longer.
yet have arrays.
Okay.
Yes. And so there's, you have to put it wherever it makes more sense. Sometimes you will put the logic that does the hard work into one of the methods, that one of the mutator methods, and sometimes, like with the balloon, we had a thing where one computed the volume of the balloon. There, it made most sense to put the logic into the getter. When the volume was asked, then you take the radius, cube it, multiply it with pi and whatever, and then you get the answer. So there's a bunch of logic in the getter. And in fact, at the point I said that's the best place to put it, you shouldn't really put the logic for updating the volume into the inflate method, because there it should just update the radius. But in this case, we have little choice, because we don't yet have the ability of memorizing more than one value. We want to put the logic into add value. All right, so now the other thing is, then we had this thing where I said, but you should also remember all of the values in a string. So I want you to kind of be able to produce like a ticker tape that just has all of the numbers in a row. So let's see how we do that. So at some point, I need to be able to say, was it get all values? Help me out. What was, I know return a string.
Get data as string.
Get data as string. Oh, that's a good method name. So I get 40, 19, 73, 28. So I get them one by one. How do I save them?
It's going to be in the add function also.
Yeah, so that's where do I save them. So over here I need to stash it away. So let me put this here. So I need to remember the new value, so I can give it later. Get data as string. So that's the where. And now the how. How do I memorize it? So did we have another problem, another homework problem that was kind of similar, where you had small pieces of string and turned them into a big piece of string?
You mean like when we made the face?
That's not what I meant.
The letter.
Exactly, the letter, right? In the letter, we added little bits of string to the body of the letter, and it became bigger and bigger. And then when we said give us the whole letter, we had it all together. So we need to kind of make this like the letter, where we have a string, and then we keep adding to that string. So what should I call the string to which we add stuff?
Data as string.
Sure. What's the type?
Int.
Okay. He said int. Let's type it all up and then we'll see. Yeah, but it can't be int, right? Because we want it to be a string, so it's got to be a string. Yes. That's right. So that's the data as string. And to that, we now need to append this number here. So over here, it's data as string. Okay, how do I append to something? In the letter, what we did is we called data as string, and then we called this concat method. But if now we are a little smarter than that. In chapter 4, in the section on strings, you learned a better way of putting strings together. How do you put two strings together really easily?
Plus sign.
With a plus sign, exactly. So I can just use the plus sign here, and then I just append the new value. So what goes on here is that the new value is not actually a string, but because it's put together with a string, this thing over here is a string, it's converted to a string, and then the two are smashed together.
So what's the value of data as string going to be the first time through?
Now,
I'm getting null, so I'm just having to do
yeah, now this man asked an excellent question about the first time through. And that is always a really good question to ask, because the first time, as with so many other things in life, is always trickier than what goes on later. So we need to figure out, how did it get initialized? So for that, since I can't paint today, I'm going to do this with a keyboard. So let's have a quick look at the data members that we have. We have data as string. We have smallest so far and largest so far. And let me just simulate a little index card here, a little sheet of paper. And now I want to run through a couple of calls. And I want to update these values. Now we have to initialize them with something. So in the constructor, which I will show you here, which we haven't written yet, another data set, I'm supposed to initialize all instance variables. To something. I don't know what yet. But we'll figure that out in a minute to one. So we could have a guess. What do you think data as string should be at the very beginning?
0.
Okay, how about smallest so far?
0.
Okay, how about largest so far?
0.
Okay, here's a man who's, if nothing else, consistent with his opinions. So now let's try. And now we're going to add the value 3. And so the code for largest so far was to take the max of this value that's in here and the new incoming value 3 and put that in here. What's the max of 0 and 3?
3.
That's 3, right? So that seems to be working well. Now, let's look for the update of data as string. So far we have 0 here, and now we're putting the 3. What do we get?
0 stays 3.
You would get 0 and 3, right? Because you're concatenating them not as numbers, but as strings. Now, is that what we wanted? No. Because the 0 was not actually part of the data. We don't really want the 0. So how can I make it so that the 0 doesn't appear?
string equals new value?
Yes, I could do that. In that case, it would be 3. That's an interesting remedy. Let's now look at what now happens when I add 13. Yeah?
Does it have something to do with like the Hello World thing in the bush where you take like the first and then it prints everything after? No.
No. No. You have to have some string. You're operating on strings. And so what he said is, he said he couldn't figure out how to do this, so he used a different strategy. He said instead of saying data as string equals data as string plus the new value, he just said, let's just do data as string equals new value. And I do grant that that solves my immediate problem, but it's not going to solve it long term. Because now when I go to the 13, then his strategy would replace the 3 with the 13, and that wouldn't work. So that wasn't a good strategy. So in that case, it would almost be better to have it like this. But I don't want the 0. Yes. She couldn't take it anymore. So you put an empty string here. And in that case, we're good, because the empty string plus 3 is, really it's the string made of 3. And then over here, it's the string made of 3 and the 13. What's the empty string, you may ask? So the empty string is like the equivalent of the number 0 for strings. It's the string that contains no characters. If the empty string makes you really nervous, just like the number 0 made you nervous in 4th grade, which you probably still vividly remember, then you could always put in a blank in here, a string containing just a blank. But the empty string is just fine. All right. Now there was another problem with the strings. Actually, technically speaking, the way that I've implemented, in the second step, I don't get 3 space 13, but I will get 313. Because when you look at the implementation, it says take the string as it was before, and it was the string quote 3 quote, smash the new value behind it. It didn't say anything about putting a space between the two. And it won't do it. It'll put them right next to each other, because sometimes that's actually what you want. So how do you get a space between the two? Yes, so you would put a space somewhere. All right. So now we would get spaces here. Now let's look at the largest so far update. So now the 13, that's going to work out fine, because here we have the number 3. The max of 3 and 13 is 13. And it is going to replace the 3 with the 13. Now when we add the value 7, over here, it's going to be added behind. Now what's the max of 13 and 7? 13. And so the 13 is going to be replaced by 13, which is good. We're not losing the largest value. Now let's try the smallest. We've not done that right now. What is the minimum of 3 and 0? 0. What is the minimum of 13 and 0? What is the minimum of 7 and 0? And now when we later ask, hey, Mr. or Mrs. Dataset, what was the smallest, tiniest, teeniest, puniest value that you've ever seen in your life? What it's going to say? But that's not true. The smallest one was 3. So it would have been better if we had put the smallest one so far as 100 million. And then in the first step, What is the minimum of 100,000,003? And everything would have been fine. Except 100 million sounds pretty arbitrary. And so that's why the description says, what are you supposed to use?
Integer dot max value.
Exactly. So the description says, use this magic number, integer.max value, which is a little bit more than 2 billion. It is the largest number known to Java, the largest integer known to Java. And nothing can be larger than that. So if you prime the pump with that, then it'll work. Which is actually kind of tricky. So that means when we ask a data set that has never seen anything at all, it's going to kind of lie the first time, right? It'll claim to have seen some gigantic thing, but we don't yet have the tools to solve that problem. All right, so that's the data set, and so it has these kind of two non-trivial components to it. One, that how do you compute? How do you look at a series of values, a value at a time? So you need to remember, what do you need to remember about them? That might be, in this case, the largest, the smallest. Other times it might be the sum or the product or a count. And you need to update that whenever you see a new value. If you think about it, the cash register did the same thing. The cash register didn't remember all the values. It remembered one value at a time. And when it saw a new value, it updated the total and the count. And then it forgot the value, moved on to the next value. So that's kind of a common way of doing record keeping in these objects. All right. Any other questions about this particular assignment? Yes? That is an excellent question. So with the largest so far, I've said, we start with 0. That didn't seem to get me in trouble because the 0 was instantly replaced with 3. So, but you have a good point that with some data sets, I would get a wrong result. Give me a data set that with my current algorithm, where I say largest so far is 0, and then I keep replacing it with a maximum. Give me a data set where I would get the wrong answer. Yeah, if all the data are negative numbers, are there such data sets? Sure, if you live in Alaska, right, and you have average daytime temperatures in centigrade. In January, it's minus 40 degrees. In June, it goes all the way up to a balmy minus 5, and it never goes over 0. So in that case, you might have all negative numbers, and then having the 0 here isn't going to work for you, because the 0 is going to mask out that largest negative number. So what's the solution? Yes. So the solution is to take and of course not that one, but the integer.min value instead. Yeah.
So how do you do the integer.min value?
In the largest so far, you do integer min value, just like that. Yeah, that's actually another good question. I think I was kind of sloppy about talking about constants. When you have a constant in a class, such as integer.min value, there's this special syntax for it, where you put the name of the class, and afterward you have the name of the constant. So here's the class name. I guess this is not so easy to do. And here's the name of the constant. So anytime that someone hands you a class that has some constants predefined in it, then you can do that. Name of the class that someone gave you, dot name of the constant, and that's how you can access it. Another example that you have seen already is math.pi. Name of the class is math, name of the constant is pi. Other questions? Okay, what was the other assignment that we had? We had the
Sensor disk.
oh, the disk. Yes. So the disk is kind of the same, has the same flavor that, and it's actually a very realistic thing because that's how these devices work. So you have this little sensor that that only sees at a time a 0 or a 1. You know, just imagine if your life was like that, that all you would see at a time was a 0 or a 1, and your entire life would be a stream of zeros and ones. And that's what life is like for this disk. It sees one of them at a time. So it has to remember something. Now you can't remember the entire stream. Oh, actually, let me go back to the data set. One person tried that. One person tried to say, well, I can have this humongous string that contains all of the data. And then I can later try to take that string apart and reconstitute the numbers out of it. But it doesn't work. You don't know enough about Java yet to follow through with that plan. So don't try that. Same thing with with the sensor, with the disk sensor. You don't store the entire stream of data because you don't need it. If you see a whole bunch of ones and then a 0, so let's see, what do we need to store? What are we supposed to count? The number of transitions?
Yeah.
Okay. So, do we need to store that number in our what was the name of the class? Sensor?
Disk sensor.
Disk sensor. So I'm trying to think of what instance fields I need.
You need an instance. You need a like transition count
Yes.
to count how many transitions there are.
Yes, I really do. Okay. What else? To see what else, remember we can't store everything, so I can't store all of the numbers. What I have to think, so I go through, I see a 1, and now I see another 1. Now what I want to argue is, because it's the same as the one that I saw before, I don't do anything. Same as the one I saw before. Same as. But over here, I see a different one. And therefore, I want to update my count. So, but I only get them one at a time. What do I need to store? So it helps to write it down in pseudocode. So if the new value is different from the previous one, then I want to increment the transition count. How do I know what the new value is?
The tester says it.
Well, I'm just an add value. I need to implement add value. So I'm just inside this method here. When I want to write its code, how do I know what the new value is?
Question.
So I'm trying to go from the pseudocode here to the actual code. And so it says if new value is different from the previous value. So I want to start writing some expression with a new value. Where is it?
So would you have to create a new instance variable for
Oh, sorry. So, so he says, looks like I have to create a new instance variable. No. How do I know what the new value is?
It's a parameter in the.
Thank you. It is a parameter to the function. It's being passed to me over here. But your moment of glory will come in just a minute. So new value is a parameter. It's been given to me. The method is called and say, hey, I have just seen a 1. Now I have to compare it with the previous value. How do I know what the previous value is? Okay, how do I know what the previous value is?
Do you have to create a new instance variable?
Thank you. Yes, for that you do have to create a new instance variable because the add value method doesn't tell you. The add value method says, hey, I've just seen a 1. It doesn't say, hey, I've just seen a 1 that was preceded by a 0. It doesn't give you that information. It told you a minute before that it saw a 0. And so now it's your job to remember that, and the only way that you can remember something is to put it in an instance variable. The only memory that an object has is its instance variables. So yes, so okay, what do you want to call it?
Pre-value.
Okay, pre-value. Can I call it previous value? All right. So now there was some trick that I told you on how to compute whether they're different, because again, my challenge is we don't yet have an if statement. Next week you can write if new value not equal previous value, but we don't yet know how to do that. And so the trick was to compute the difference, and because there are only zeros or ones, the difference between two zeros and ones can only be 0 plus 1 or minus 1. Right? 0 minus 0 is 0, 0 minus 1 is minus 1, 1 minus 0 is 1, and 1 minus 1 is 0. So we take the difference. Now if they're the same, that difference is 0. If two numbers are the same, their difference is 0. But if they're different, then it's either plus 1 or minus 1, and that doesn't really work because I want to get a plus 1 in both cases. So how do I turn a plus or minus 1 into just a plus 1? That's where the absolute value comes in. The absolute value of minus 1 is plus 1, and it doesn't disturb the others. So, and again, if you just want to play around and see what the absolute value do, we can just try this here and compute math.abs of 0 minus 1, for example, and it tells me it's 1. All right, so that's the value that I need to add to the counter. So I thought that was a nifty trick, actually, to update this counter. Right? It either doesn't change it if they're the same, or if it adds 1 if they're different.
We need to add the variable counter though.
I think we added, and it just was called transaction count or something.
Did we already learn what plus equals means?
No,
Okay.
but I thought I put that in there so if anyone watches the video, they learn something.
I think it's just count or
Oh, it would-
transition count.
It's called transition count.
Yeah.
Okay, whatever it was. All right, now let's play through this one here. And again, I can't overestimate how important it is to do these little role-playing things. So we have transition count, and what was the other one? Previous value?
Is previous value also a private integer?
Yes.
Just an instance variable.
Yes, that was exactly his point, that we need to remember it. So let's have our little scenario. What's transition count at the beginning?
Empty quotes.
Is it? Why can't it be empty quotes?
Oh, well, yeah.
It's an int, right?
Right.
And empty quotes would be strings. So but I mean, there's nothing wrong with just thinking about it as long as we can correct ourselves. So the previous value, that's a bit of a problem that I didn't quite know how to deal with. For right now, I'm going to set the previous value to 0. So now we add the value 0. Now 0 minus 0 is 0, so the transition count is going to stay 0. So we get another 0, transition count is going to stay 0. We add 1. 1 minus 0 is 1. Absolute value of that is 1. Transition count goes up from 0 to 1. That's beautiful. Let's add another one. 1 minus 0, because the new value is 1. Previous value is 0. 1 minus 0 is 1. Transition count is what?
1.
Not the way it's coded,
Oh, transition code.
because it says transition count equals transition count plus that difference. And the difference from
So,
new value and previous value is 1.
so it'll be 2.
It'll be 2, but we don't want it to be 2. What did we fail to do?
Oh, we have to make the previous value equal the value in the at the end of every.
Very good.
Value.
Okay, so what we have to do, and we hadn't done that, we have to, at the end of add value, we have to remember what the previous value was. So when the next call to add value comes in, at this point add value is 1, and now the previous value has been updated. And then we won't have this mistake here. And so we really have to do that. You have to, at the end of the call to add value, you have to update the previous value. Now that happens up here. So we're called with a new value. And immediately after this method exits, that value is no longer new. That value is the previous value, and you need to remember it. All right. So again, I can't overemphasize how useful it is to take out a sheet of paper, and I'm sorry I didn't use the whiteboard here, to take out a sheet of paper and to scribble these things on there, simulating some in your mind a few method calls. Write down the list of the method calls that you want to simulate, and just see how do the variables update, and what's important is how do they update the way that you're actually implementing them, not the way that you wish they would update. All right, well, that took a long time, but that's all right. I do think I want to I want to do a bit of the lab because there's something that I want to show you in the lab. Is there any other question that you guys had about sections 4.4 to 4.6? All right. Well, let's get in the lab and then we'll catch up with that on with whatever remaining issues are on Thursday. So. Which lab are we in? 5 now?
5.
Okay, well, all right, and if we could please change the order where I'd like you to start out with part C and then move into A and B. And the reason for that is that C goes to this really nifty tool that now I guess I do need wireless. Maybe have a wired. So there's this site called CodingBat that has a whole bunch of Java problems. So I'll just go into icy hot here, and no, we don't yet know how to do this one. That's why I picked the one that I picked. It says, given a string, take the first 2 characters and return the string with the 2 characters added at both at the whatever. Oh, I see. So here they have an example. The example makes it clearer. Here, read through this. And so it says when we have like the string kitten, we're supposed to like take the first 2 characters, and then we're supposed to take those and stick them both to the front and to the back. Why? You never ask why with CodingBat. It's just the way it is. That's what he wants you to do. And so let's just quickly do this. So we return well, whatever, string, substring, 02 plus string. And now I say go. And over here, it gives me my result. And it says, bzz, bzz, bzz. And it tells me here what my result was and what it expected. So here I gave it the ki kitten, but it wanted the ki kitten and another ki. So I misunderstood it, I guess. So let me fix it. And now let's run it again. And look at that. Isn't that nice? So now I got green in almost all of the cases, except
2 of them.
in these 2 cases, and here the problem was that the string he gave me was too short. Then I tried to extract the first 2 characters. And am I giving a tip on how to deal with that? No. So unfortunately, it's just a little bit early for us because we don't quite know how to do those parts. So you won't be able to pass those 2. It needs an if statement, and we haven't yet learned how to do that if statement. So you just need to be satisfied if you pass in all of these cases. But pretty soon you're going to learn how to do an if statement, and then you need to be able to fill in the other cases. The reason I want you to experience CodingBat, and I'm going to put it on a bunch of other exercises too, is that if at any point you feel that you need more practice, that you just want to practice some simple coding so that you can get the basics right, CodingBat is going to be your friend. And so we're going to be very soon in a situation where you can do all sorts of things, where you can practice all of these things very, very easily. I'm just going to pick another random one. Can you do this? No, you can't get. All right, so but just go through the ones that I gave you. I just want you to experience that side. And then go on with problem 1, which is a very straightforward math problem. Now it asks you to compute the distance of 2 points on a plane. And then I figured, well, we don't live on a plane. It might be more interesting to compute the distance of 2 points on where we live. And that is a little bit harder, but it's not infinitely hard. You can do it. So I'm giving you the formula thanks to that fount of human knowledge, Wikipedia. And it's mildly tedious, but not impossible to implement that in Java. So let's see how far we get with that. And we have, what, 15 minutes? Okay, we may not get very far with this. So do the coding bat stuff and submit what you have, and I'll probably just reopen that for Thursday. Sorry that I took so much time with the homework.